Light or electromagnetic waves, or now we learned photons, emitted by a bulb, has three basic properties. One of them is, so because it's a huge object, so from different parts of this bulb, these photons will be emitted. So different parts of the bulb is independent from one another. If the sources are independent from one another, so waves cannot be coherent. Yeah. So that's why photons emitted by this bulb is going to be incoherent. One of them is this, basically. Second one is, they are, as you see, moving in different directions. So they can illuminate everywhere, but their intensities are decreasing as they travel. Like closer distance, more intense, but far distance, less intense. And also, because there are multiple transitions from atomic energy levels to lower energy levels, remember there can be multiple transitions. So different wavelengths, different color includes in this light bulb. For that reason, we said that these two bulbs can never form an interference pattern on this ground. Interference occurs, but conditions changing continuously. One plate destructively interfering, next one is constructively, but quick is changing, so we cannot observe this interference pattern by using two light bulbs. But another light source we have called lasers, they are completely opposite. Yani, if this is incoherent, laser is going to be coherent. Moved in different directions, no, lasers are in one direction. And different layers, no, wavelength has single wavelength. Lasers. But how do we do that? How can we succeed? This now we will talk about it. Lasers produce a narrow beam of coherent light. And monochromatic, as we said. Which means single color, single wavelength. And also coherent, not only coherent, in phase as well. Because coherence is possible, out of phase coherence can be possible as well. But these lasers are coherent and also in phase. And when they are in phase, what happens? Look at them. This is the model for waves in the laser. Crest, 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 crest. So they constructively interfere. If waves constructively interfere, what happens to the amplitude? Increases. So RAM power and energy and intensity of the light increases. That's why lasers have very intense light. Because they are coherent and also in phase. All waves constructively interfere and produce a very intense light, very powerful. And definition of the intensity in here and definition of the intensity in chapter 4 not different, in fact. Intensity is a measure of the energy transfer per unit time over a given area. Maybe you remember the equation chapter 4. I is equal to power divided by area. Area was the surface area, remember? We did this before. Power is, how we calculate power? Delta E divided by delta T. If we divide this by area, we calculate the intensity of any wave. It can be sound wave, it can be electromagnetic wave. So intensity is energy transfer per unit time over a given area called intensity. It's also defining the intensity of the laser. And lasers, another property is one directional. But light from a bulb, it was in all directions. How we know that? Because it illuminates everywhere. But laser is not there. Where do you hold? Lasers only illuminate that region, that point. One directional. That's why this makes lasers able to travel very long distances. Lasers can travel very long distances. Can travel very long distances. So what does laser mean? Laser means light amplification. In fact, you know what an amplification means? Increasing the amplitude. Right here, what we get? By making them coherent and in phase, we increase the amplitude of the wave. Light amplification. Yes, we amplify the light, but by using a technique which is known as stimulated emission. Stimulated emission, I will explain in the next slide, of radiation. Yeah, combine this all, it becomes laser. This is a question. Laser means what? What does laser mean? Light amplification of stimulated emission of radiation. It's called laser.
Stimulated?
Stimulated, yeah. What does it mean? The next slide. Stimulated. In fact, we have two emissions in atom. One of them is spontaneous emission. We know about this. When electrons are excited to higher energy levels, they can transit to lower energy levels on their own. So this is called spontaneous. Yani suddenly they choose a way, they transit from 5 to 1, 5 to 2, 5 to 3, 5 to 4, depending on their choice. This is not determined by us. Spontaneous emission. But now, stimulated emission will be slightly different. We will determine that. From which transition they have to do.
Stimulated?
Yeah, stimulated is that. In detail I will explain. Not spontaneous. They're different, completely different, opposite. But to make light, to produce a light for them, we have to give energy to a medium, to a gas, to a liquid, or to a solid. It's a substance. And you should give energy to a substance first. You should excite electrons from ground state to higher energy levels, and they will turn back to lower energy levels, and they will emit light. These substances are named in here as active medium, in which we are going to add energy. It can be gas, or liquid, and solid, depending on the purpose of the laser. But energy must be added. Generally, batteries are used for lasers. And energy can be added, electrical energy can be added by using batteries. Or sometimes chemical energies. You can produce some chemical reactions, and chemical reactions also produce energy you learn in chemistry. So, active medium can absorb this energy and then excite the electrons higher energy levels. Then when they turn back, they emit light. If they emit this light on their own, it's spontaneous emission. Every different wavelengths are possible from different transitions. But in laser, it's not going to be this way. We will get coherent light, not only coherent, one wavelength, one directional, in phase, and we need identical photons in lasers. And also we learned that composition of the active medium, yani type of the gas, type of the solid, or type of the liquid determines the energy, determines the color of the light, because for each substance, energy levels are different. That's why each photon can have a different. Remember in the last lesson we talked about that in this auroras. Yeah. Because in the atmosphere we have nitrogen and oxygen mostly, the color was green and red. Similarly, composition of the active medium and type of the substance you use will determine the color of the light sent by this medium. Now let's learn how we can make single color in a laser and stimulated emission. What is stimulated emission? Okay, first, we need energy to add active medium, excite electrons to higher energy levels first. When energy is added to active medium, atoms absorb energy and excite higher energy level. If you leave them alone, they will transit to lower energy levels, and then they can transit in multiple ways. Multiple transitions can produce multiple wavelengths. So it's not a laser, ordinary light.
Going to different directions.
Yes, and also. But we can do something. What? When these atoms are excited to higher energy levels, and electrons are excited to higher energy levels, you are going to send a photon from outside. For example, I want blue laser. You are going to send a photon which is blue through this active medium. As soon as you send this photon to active medium, this time, these atoms starts to emit identical photons which you send. Identical photons. Yeah, if you use the photon of 2 electron volts, which is say blue, all emitted photons by this gas active medium is going to be 2 electron volt, which is blue. This is called stimulated emission. Yeah, you don't let atom to behave itself. You are determining that. When light, a photon, of a certain wavelength, which means certain color, is applied to the excited atoms, in active medium, they are induced, they are triggered, they are stimulated to release a wave with the same properties, a photon with the same property of the incident photon you sent.
The one we added.
Yes.
No.
Then, one by one, atoms are starting to emit those photons. But these photons are, as I said, are equal, identical. After one atom spontaneously releases its energy in the form of light wave, identical to the photon we sent, to the active medium. All other energized atoms releases their excess energy as waves, photons, with the same wavelength, because identical, with the same phase and same direction. So this process is known as stimulated emission. Stimulated emission, if I make a model, it's something like this. For example, say that you are a student who like clapping. Clap, yeah. You see that randomly. Stimulated is this. When I say 3, you are going to clap. Ready? 1, 2, 3. You see that? As soon as I said 3, you clapped. I stimulated you. You were doing it randomly, spontaneously, on your own. But now, as an outside source, I told you that you are going to do this when I say you.
You stimulated.
Yes, I stimulated this group, how they have to clap. The photon we send is doing the same thing. When we send this photon inside this active medium, all atoms are stimulated by that photon and all are starting to emit a light with the identical wavelength of the incoming photon to this medium. Another example. Sometimes you see that birds are standing on a power line in groups. So, if these birds are flying on their own, one by one, it is spontaneous. But if I hold a rock and then send a drag to them, so they are going to fly together, right?
Yeah.
I am stimulating them to fly at the same time. Similarly, what we send the photon is doing the same thing. The photon we send is similar to rock. I send to those birds, and then all they are starting to fly. What stimulated emission? From an outside source, you are giving an order to the atoms of this medium. You are going to emit a photon, but identical to the one which we sent into the active medium. This is what stimulated emission. And after this stimulated emission, all the photons are identical. And they have same color, same phase, same direction. That's what intensity becomes that great. So now, this is the structure of a laser. A laser has 3 basic components. One of them is absolutely we need some substance to excite atoms, which is called active medium. It is this active medium. Second, of course, you need an energy source to excite the atoms. So this energy source generally can be a battery. Excitation source, it's a battery. Third, you need mirrors. Each mirror is put at one end of this active medium. One of them is in here, the other one is right there. But one mirror is completely reflective, reflects all the photons back. But other mirror is partially reflective. And it lets some transmission of the light through this mirror. Third component is the mirrors. Why do we use these mirrors? Now we will explain. Mirrors are used to produce more intense colored light. How? This diagram is representing how photons are produced in a laser. First we send single photon from outside. Then this photon meets an electron in this active medium, the atom in this active medium, tells this atom, release a photon identical to me. As soon as this photon meets this atom releases a photon, which is identical to this one. Initially we were just one, until now we have two photons. So initially one photon, now 2 photons. But each photon now goes another atom. Second one goes to another photon and stimulates it, and then number of photons increases 1, 2. Also this one goes another atom, 3, 4. What happened? 1 photon changed to 2. 2 changes to 4 changes to 8 changes to 16 to
32.
now after each stimulation, number of identical photons are increasing. So then, because they are constructed with gravity, what do you expect intensity to be? High intensity. Intensity increases. But we need a specific intensity to burn something, for example, the laser. If this specific intensity is not provided, until this sent photon, this sent photon Y2 arrives in here, this partially reflected mirror reflects these photons back into the active medium again. Yani while they are moving from left to right, they are stimulating and then intensity increases. When this light arising here in partial reflective mirror, if they are not enough intense, they reflect back into the active medium again. So as they are moving in actively, what happens? They continue stimulating more and more photons, and the number of photons increases. Once again reflects. Finally, it gets enough intensity. When it gets enough intensity, it leaves from this partial reflective mirror. So, mirrors on the ends of the material returns coherent light waves into active medium where they stimulate the emission of more coherent light waves, more coherent photons. And as the light passes backward in this active medium, it becomes more and more intense because the number of photons increases. One of the mirrors is slightly transparent. Which one is this one? Which allows some of the intense coherent light to be emitted by the laser. Then the laser starts operating. This is how laser works. In fact, it is more detailed, but you please explain to that extent. How you are giving the order to an atom is a little detailed normally, not that easy. Yani, as soon as you say, atom releases this photon, they don't do that. You should do something. It's not explained, that's why we skip this part. So, lasers are operating between infrared, far infrared, and X-rays. Which electromagnetic radiation exists between them? Ultraviolet and visible. Yes. Yeah, the laser generally used are in the region of visible light, which generally children are playing with them. Also ultraviolet, not visible, but very high energy. Especially for cutting metals, they are using the ultraviolet, high energy photon lasers. And also there is another type of thing which is called masers. Masers are also operating in the same method. However, their operation regions are different. Microwaves. Masers are devices similar to lasers but operate in microwave regions. So take this M, put in here, change laser to maser. This is also Mr. exam question. So masers are the devices similar to lasers but operate in microwave regions.
So teacher, lasers only operate from visible spectrum
and ultraviolet.
Not infrared.
No, not. X-rays. X-rays are produced only by a different way. You cannot use atomic excitation for X-rays. X-rays are produced when a proton or a charge strikes the nucleus of an atom. It's a different way you get X-rays. That's why it's not X-rays. Yeah, only by atomic excitation you can get these two and lower masers. Lasers are very important devices. They are used in very wide range. For example, because they are one directional, they can travel very long distances and very easy to measure distance with lasers. Now they are holding the laser just like this to the wall and then quickly finding distance between the wall and you. So lasers can be used for measure large distances because it can be pointed at distant reflectors. You send a light, there is a mirror reflects it, and then because it travels with the speed of light, you can easily measure how much is the distance. Even there's written that Earth-Moon distance is measured by this way. They put a reflector on the surface of the Moon and send a laser, so it reflects the light. If it's come back, speed of the light, you calculate how many seconds does it take, you find the distance. Lasers. Really effective for measuring distances. Also, laser can be measured distances with great precision, and so accurate in their measurements. Geologists use repeated measurements to record changes in the height of the Earth crust, and year by year, is an increase or decrease in the height of the Earth crust. They are measuring this way in recording data from different parts of the Earth. And the lasers improve information storage and retrieval is coming back. You store it and come back. Get back, sorry. A recent application of lasers is compact disc. It's not recent anymore. 20 years ago it was recent maybe, but now nobody is CDs or DVD players. See, I talked about the CDs at the end of section 2. So you are holding the reflective surface and laser is burning, making bits.
Yeah.
0101 is the language for decoding, the recording information. So lasers are used for burning and also reading, taking information back again, and then playing music, whatever it is. Principles behind the reading the information stored in the compact disc also bases for reading the barcodes found on many products. In supermarket, you go and then you take a cola. You go to the cashier. Cashier is using that red light, holding somewhere, and they're reading that because the information is coded in here. And you read this information by using laser. That red light is laser. This is an exam question. I think this is one of the asked one. All are important. All must be known. They can ask all of them, but this one is asked. Lasers can be used to lighten and remove scars and certain types of birthmarks without affecting surrounding tissues. Check it. It's a cut, but now by laser, it fixes. Lasers have a very wide range of use in the medical science. Let's see. Carbon dioxide lasers can cut through the muscle tissue by heating and evaporating the water contained in the cells. Inside the cell, you evaporate them by using lasers. But
what is that?
carbon dioxide lasers, huh? Why do they do? I don't know. Why do they need?
What is the purpose?
But for this one, I can't say what the purpose is. Second one, the energy from a laser can also coagulate blood in the newly opened blood vessels, thereby reducing the blood loss and increasing the risk of infection. So, for example, bypass, so much blood. So, if the blood is contains so much water, it can bleed very quickly. And when you vaporize the water, so this time you are decreasing the bleeding rate, and then you are decreasing the blood loss. And they are using, I think, laser on open vessel or open places to decrease the blood loss. A laser beam can also be trapped in an optical fiber endoscope. This is very useful nowadays, optical fiber endoscope, which can be inserted and directed into body structures. For example, stomach. You have a stomach ache. You want to know what is the problem. They are inside from your mouth and then sending to your stomach, and that watching it. It's like TV on a TV. So this is as a result, surgeons can stop internal bleeding or remove tumor without performing massive surgery. And even they can fix the problems. They can understand the problems. What is that? Especially for stomach, they use so much. And without cutting, we can watch the problem, which is optical fiber endoscope. And lasers can pass through the outer structure of the eye, such as cornea. Yani so much use about the eye, the lasers. Without damaging them, therefore lasers are effective at treating lesions in the inner eye. Yani sometimes my eyes also have that one. Some oils are starting to accumulate on that part. Then it becomes larger and larger. When it's larger, it stops also blocks your vision. In this case, they are using a laser and then removing it. Lasers operations. And also, lasers are used for eye surgeries, including the surgery to correct glaucoma. What is it? The condition in which fluid pressure is within the eye is too great. If fluid pressure is too great, most of them they are vaporizing some of them and then decreasing the pressure. Lasers can also be used to correct nearsightedness. You are unable to see the close. You are using eyeglasses. After 18 years old, you are going to go to and then they are going to laser, right? And you are going to throw the eyeglasses, and that's how they use this. And those are where we use the lasers, and better to know them, okay? In titles, how and what, and we don't care so much, but what is it? Lasers use where, you have to know that.